everyone. Hello and welcome. This is Aurora with the Central Coast Astronomical Society. I want to extend a special welcome to you. We have so many fun things planned for you tonight. We are going to be looking at the night sky, and we're also going to be looking through a telescope. We are going to be talking about equipment, what equipment you should buy, what equipment you should stay away from, and you're also going to be able to hear from real astronomers tonight all the different things that are up in the night sky. You don't need a fancy telescope. We are going to be taking it straight from the top. So everything that you need to know about what our goal is, so you can go outside, look up, and really know what you're looking at. So I'm really excited to be joining with, for you guys to be joining with us tonight. If you could, go ahead and take your fingers and put them on the keyboard and tell us exactly where you are in the world, so we can, astronomically speaking, kind of speak to your area of the sky. We've already picked out a couple of areas we're going to focus on, but we are also open for also new suggestions and ideas, and if you have questions. There is a download that goes with tonight's presentation. It is right underneath this video. So if you got here from our website, back on the website there's a button that says download this handout, and you'll see it here. I've left some areas for you to take notes, so the whole thing isn't just filled, but you'll be able to follow along for tonight. If you don't have the handout, don't worry. You can totally participate. Just go ahead and enjoy the show. If you have any questions, I don't know if you know, it looks like the chat box is exploding already. And you'll be able to ask questions, and our happy astronomers from Central Coast Astronomy and Dark Ridge and Riverside will all be helping answer those questions for you and get those questions answered. Myself, I will be not moderating, what's the word? Facilitating, hosting tonight. Thank you, Brian. And with that, let me introduce some of the other astronomers for tonight. Well, first of all, come here. This is my husband, Al. I want to bring him on board because without him, probably wouldn't have had a show tonight. We had a little bit of a computer challenge. So he's the one who got me my very first telescope maybe 15 years ago. And without you, I really wouldn't be doing this. So thank you.
Well, we're glad you are.
So thank you. So
have fun.
We will. So all right. So let me introduce some of the crew to you tonight. Brian, are you here?
I am here.
All right. Let's see your face. There you are. Hi, Brian.
All right. Hi.
And wait, you're not here yet. You're not really here.
Oh, I'm not really. I'm only partially here.
You're only partially here. I need to remove myself, and now you're here. There we go.
Hello.
Hi, Brian. Do you want to give us a quick 1-2 sentence thing or 1 or 2 minute thing about
Sure. Yeah.
Okay, go ahead.
So my name is Brian Cox. I'm a member of Central Coast Astronomical and also Riverside Astronomical down in Southern California. And I've had the opportunity tonight to set up my 120 millimeter telescope with a video camera, and which I use to take the picture that you see in the background behind me. And so we're going to show you the moon and some other objects, some of the key things that Aurora and Kent talk about. So I'm looking forward to it.
Awesome, thank you. And I forgot to get a picture of your setup, so
I have that whenever you'd like to.
Do you want to show people what it looks like near the end when we talk about equipment?
Yes, absolutely. Okay. Sounds like a good idea.
Yeah. Okay, let's do that. Perfect. Okay, great. And to go ahead and get started for tonight, we're already getting peppered with questions. So we're gonna get rolling. So real quick, a couple of quick things I want to announce for tonight. Tonight you can just the handout is yours. It's free. This is a free online stargazing session. We're gonna be covering 4 different constellations and a whole bunch of stuff inside of them. It's just I learned a lot going through this with Kent. Kent is our astronomer for this evening. Before I bring him on, because he's going to completely floor you with his knowledge. And I wanted to also make sure you know to download your version of the sky map. Go to skymaps.com. I think it's .com, skymaps.com or .org. No, it's .com. And you can download this one for your hemisphere. And how you use this is they're really similar to planispheres. If you've ever seen these, they have a lot of information, sometimes too much information to really make sense, and it's printed small, and then you gotta go outside where it's dark and it's hard to read. So these can be a little frustrating. I like to have one, even when we were at Mount Wilson Observatory, huge telescope. The operator of the telescope had one of these right next door to him. So, so they are useful. One of the ones I like to do is have one that's just for this month, and that's where you can get this handout. It's free. how you use it is there are 4 directions. We have north, south, east, west, and it goes over your head. Whoop, and it goes over your head just like this. On the back side, it tells you what's up in the sky tonight, which we'll be going over. And so you're going to line up the north with the north, and then it's showing you what the night sky should look like if you were looking up. So this is a great tool. You can write on it. It's not like an app on a cell phone. Those are great too. You can use Sky Safari or Stellarium or whatever your favorite app is for astronomy. That will also get you going in the night sky, learning the constellations. So that's a great, so these are just tools to use as you go along. And so the last tool that we're going to talk about tonight, I'm just going to show it to you really quick right now. I just took this one off my wall. I have the one for 2021 right now up on the wall. This is a really awesome chart. It's one of the best ones out there that shows you the quick year at a glance completely in here. So this goes from January all the way down to December. You'll notice the summer months for the northern hemisphere are shorter. So this is sunset and midnight and sunrise. And in December, in the winter months, in January and December, they're longer. And so what this shows is how the planets, the moons, where the meteor showers are, what that looks like during the night sky, during the course of a year. You can't get that from a zoomed in view on an app. So I really like this. My kids look at this all the time. They're like, hey mom, you know, Jupiter's rising in an hour. Let's go check it out. And they can just tell that from one quick glance. So this you get from Sky and Telescope. It's usually like $4 or $5 for the entire year. So that's another good one to do as well. All right, Brian, did I get all of it? Did I mention everything?
I think so.
I think so.
Yes. And we already have equipment questions coming in, so I'm letting people know that'll be later in the show.
Yes, yes. I will tell you, don't buy this, buy this. Yes. So we'll go over all of the equipment stuff. I look like a telescope store. I look like an indoor observatory right now. So we'll be talking about more equipment near the end of the show. So save your equipment questions. We'll get to them, I promise. Okay, so let's go ahead and get going. If you guys are ready, put a big old grin on your face, grab your pencil, grab your highlighter so you can highlight some of the stuff we're going to talk about here, make as many notes as you can, and let's get going. Kent, are you there? Hello, Kent.
Hello, Aurora. I'm there.
Hello, Kent. So for those of you who are new, this is Aurora and Kent and Brian from the Central Coast Astronomical Society. We are doing a tour of the night sky, so you can go out tonight, look up, and know what you're looking at. You only need your eyeballs. If you have small binoculars, great. If you have a small telescope, great. It's not needed, but we're going to focus on things you can see, but mostly in binoculars or a really small telescope. Okay, so what you may not know about Kent is he's just sitting there talking to us about astronomy. He's not looking at stargazing programs. He's not looking at these really fancy charts. He's just sharing his passion and his expertise and amazing knowledge of the night sky. He's just sitting, are you on a couch right now, Kent? Or are you just relaxing somewhere, right?
I'm sitting on a hard chair right now.
Sitting on a hard chair, okay. So this is Kent. He actually doesn't have a webcam. In the past, he's connected from a rotary phone, which is quite the thing to get it to work with Zoom. But so he's got a dial-in phone this time, and he's just sitting there on the phone talking to me right now. So you'll be able to hear him. You won't be able to see him, but I've got a few pictures of him. So Kent, you want to tell us about that very first telescope that you ever had that you really, really got a lot of good use out of?
Yeah, that's my old C8. That orange tube is the earlier tubes. The later ones after Halley's Comet were black. And that telescope has gone with me all over the place. It's been actually my first trip to Australia. I took it over there, hauled it on as luggage, about 130-pound load of luggage.
Wow.
And spent 3 months in Western Australia looking for planetary nebula.
Nice.
So that was a lot of fun.
Awesome. And then after you were done, when you were ready to upgrade, what did you upgrade to?
I went to a 20-inch scope, from an 8-inch scope to a 20-inch scope. Whole brand new universe. It took me about 2 magnitudes deeper for going for faint planetary nebula, or actually about 2.5 magnitudes, because I could go from roughly close to 15th magnitude to 17.5 magnitude. But you can see there's a lot more work involved because it's a bigger scope.
It is. I notice you're on a ladder here.
Yeah, that's my home scope there. The one I leave home, the brown one, and then the lighter colored one is actually a breakdown prototype I hauled to Western Australia 3 different times.
That's
or at
right.
least for 3 different trips.
This is the mirror you shipped, right?
Yeah, that's the mirror. What I did was I had a friend in Western Australia, Andrew Lockwood, and he once I air freighted everything to Perth, he held on to the structure, and the mirror would go back and forth. I'd freight out the mirror, for each trip, and then send it back home. And it's the normal mirror that goes in the brown scope. You can see down there in the center. And because the mirror is worth more than everything else put together.
Yes.
I mean, that's the way with mirrors.
Yes.
Good mirrors are expensive, and this is a good mirror.
Awesome.
And so that's why I had that really nice case for it.
Nice. Oh, I forgot to mention, Kent, before we get started, if those of you viewers out there, welcome. We'd love to have you as part of our show tonight. We'll be together for probably an hour, maybe a little more. Equipment stuff, we talk at the end. And Dave Majors made a good point. We usually don't see Kent near a star chart when we're at a star party. So he's usually already doing his stuff. Not to say he doesn't use one or know how to use one, but it's just he's amazing. If you have any questions, please type them in the box. If you would like to email your question, send it to questions@centralcoastastronomy.org. You see it down there, questions@centralcoastastronomy.org, or you can text it. If you're watching us from like a smart TV thing, I don't know how they work, but you do. You can also text it. Don't call, there's nobody there, but we will get this text converted to an email, and then it sends it by email to us. I'm going to say the number twice, and then I'm going to make both these things go away. So please write them down because they're going to disappear during our show. It's 805-242-6415. Again, that text number, if you have a question and you'd like us to read it and answer it, 805-242-6415. Okay, you guys ready? All right, Kent. So tell us, Brian, do you want to go ahead and pull up your image, and then Kent, would you like to get going, letting us know?
Yeah, let's start with the moon there. Brian had a nice image of the moon there.
All right, let's go ahead and share. This is a live view right now from Brian, and give me just a second here to bring it over to you. There you go. All right, so Brian, this is a live view, yes?
Yes, it is.
Okay, awesome. So Kent, what do you want to tell us about it?
Well, it's 3 days past new. It's a waxing crescent moon. So waxing means that each night it's going to get a little bit larger. But right now, it's really pretty in a telescope, even a small telescope. You can get a nice sharp focus along the terminator, which is the shadow and the lighter area. It's really fun to do that. And, basically the contrast will be really nice. And even with binoculars, you'll look up with binoculars, you'll go, man, look at all that stuff I can see, like the Maria there. There's a black Maria just off the center of the crescent there. And so, yeah, it's really pretty right now. Or if you just want to, just go out and look. It's up there in the sky. You can see it with your eyes.
Yes, or binoculars. Yes, awesome. Okay, great. And then if you wanted to take a look at something besides the moon that's easy to see, what would that be, Kent?
Okay, right now, Mercury is rising. And towards the end of the month, it's going to be out of the twilight and into the dark. It's having a peak around the end of the month there, and if you had the 2021 almanac, you'd be able to see the loop. But if you look at there's one where you can see it loops up into the dark. It kind of leaves the twilight there, the light blue, and goes in. You want to catch it at the peak. That's the easiest time, and Mercury will be in the west on that side of the chart. On the other side of the chart is when it's in the morning, and you'll get, once it disappears on one side of the sky, like the evening, it pops up in the morning. You'll see the arc of Mercury going around there. And Venus does the same thing, but on a lot larger scale, because both Venus and Mercury are interior planets. They're closer to the sun than we are, but you can get some really big arcs because Venus is further out.
There we go. And I know this is 2021 or 2020 from last year, but you'll see similar trends on the 2020.
Oh yeah, the idea is the same.
Yeah.
There, it's nice. It'll tell you, like, if you want to catch Venus at its highest point in the evening, you can look at the chart and go, okay, it's this time of year. Mm-hmm. So yeah, the chart is really nice to have.
Yeah. Very much.
And if you subscribe to Sky and Telescope, you get it free.
That's
which
true.
Is nice.
In January, they send it out for free. Nice.
Yeah, that's a nice thing about Sky and Telescope.
Awesome. Okay, so on our handout, we are on page 3. So I'm going to get my planetarium software. We're going to take a look so I can show you when you go outside and look up what it's going to look like. Kent, you want to start us off with
one other thing.
Yeah.
We've got Mars.
Yes, tell me about Mars.
The planet. Mars it's almost straight up. It hurts your neck to look up that high. Yeah. I mean, it's about directly, it'll be this, bright orange star. We're leaving it behind, so it's getting smaller. We go faster in our orbit because we're nearer to the sun. Mm-hmm. And so we're leaving poor old Mars behind. But, for looking at it, it's straight up. So you're looking through minimum atmosphere. And so Mars, if, you've got really good seeing, you might be able to still pull in some nice detail on Mars.
Nice. Okay, great. All right, so what you're looking at now is the planetarium software. And Kent, do you want to just outline real quick I've got the boundaries up. I don't know if you guys can see.
Oh, good.
Okay. So,
yeah, Fornax. Yeah. In fact, I can see Fornax there. You want to start? That's the first constellation that we're covering. It's about dead south now, and it's a modern constellation. Lecaille invented it in 1763. And we talked about them last month. There's really not much to it. There's a couple of faint stars. It's kind of rectangle, and it's kind of squished into the left side of the river, or the western side of Eridanus, which is the river. But you can see it's roughly a rectangle. So it's not very spectacular to see as a constellation. And this, Lecaille liked modern instruments, so he also invented microscopium, which is a microscope, and telescopium, which is a telescope. And for some reason, he liked the furnace, so he threw that one in. And that's one that we've got, but there's some neat objects.
Yes. Do you want to talk about how to find it? Because, when they go out, people are not going to see these little blue lines.
Yeah. I mean, there's unfortunately there's no boundary lines. You can see, roughly straight south helps out a lot. You can see it's a bit off to the right from straight south, but if I have to find that, I probably start with the circlet in Cetus, the whale, and then kind of drop down from that. And there it is. You've got the circle, or the circlet, and you got the bright star in the circlet, and then you just kind of drop down. There's 1 star, 2 stars, and then you get in that general area. I think that's the alpha and beta Fornax. I mean, I think the brightest star is 3.8. So, I mean, they're both faint stars.
Yes.
But you basically need a map to go after the objects we're going to cover in Fornax.
Okay,
but
great.
They're really neat objects.
Well, let's start with the first one.
Okay, the first one is called the Robin's Egg Nebula. It's also NGC 1360. It's a planetary nebula, and the reason it gets a robin's egg is it's a little bit rounder on one end and more pointed at the other. And the amazing thing is, in my 20-inch, you can actually see the shape.
Wow.
It's visible from California. I used to show it to folks in the autumn at the California Star Party. And also it shows up in an 8-inch. You can't see the shape that well, but you can tell there's a central star and a fuzzy area around it. And It's big. It's 460 arc seconds by 320 arc seconds. So it's really a big planetary nebula, 3 light years across, roughly about 1,500 light years away. It's actually magnitude 9.6, but it's spread out somewhat. And then it has a central star of 11.4. It was discovered by Frederick Winicki in January of 1868. Trying to find out who discovered it, there was a lot of confusion because one of the catalogs listed the wrong guy and a wrong date. So it drove everyone nuts for a long time. But one other thing you can see is the two stars, the two relatively bright stars in Fornax, the Alpha and Beta, roughly point towards the robin's egg there, or NGC 1360. The older Sky Atlas 2000 actually has it plotted, but for some reason when they came out with the second edition, they removed it, which I have no reason, I have no idea why. But in the second edition, I mean, it can be seen in an 8-inch scope. It should still be in there, but someone made the decision to remove it. So if you have a second edition, you just got to pencil it in.
Interesting. Okay, great. And I know for those of you who are new to doing astronomy with us, Kent actually corrects books and computer programs. So through his knowledge of the night sky. So his information he's giving you tonight is as accurate as you can get. Okay, so
it's good having a massive library.
It is good having a massive library. Awesome. Okay, now there's another one here you wanted to talk about, right?
Yeah, it's NGC 1365.
Okay.
It's like an arc-type, beautiful barred spiral galaxy. And by barred, it actually has a bar across the center, and you can see how the arms arch above and below it. It's kind of like a Z shape almost. And it's really a nice galaxy. It's about 60 million light years away, and it's part of what they call the Fornax cluster of galaxies. And in fact, we're not going to go into any detail on it, but there's an area where if you have like a 1-inch eyepiece, you can see 9 galaxies in not a 1-inch eyepiece, but a 1-degree field. You can actually see 9 galaxies in a 1-degree field in like an 8-inch scope. And I've done that years ago. Sat down and saw that cluster, but none of them are as cool as this one with the shape. It's also called, I hadn't heard it before, but it was on one of the atlases. They call it the Fornax propeller because it's got the arms on it with the line across. So it's something like a propeller.
Yeah.
And that's one of the nicknames. It was discovered by James Dunlap in September 2nd, 1826. It's magnitude 8.6, and it's fairly good sized. It's 11 arc seconds by 6 arc seconds. So the bar itself is about 94,000 light years across.
Wow.
Where if you throw in the arms on either side, it becomes 160,000 light years across. And, our galaxy is roughly about 100 light years across. So that gives you some sort of idea how big this thing is.
And it's going fast, too, isn't it?
Oh, yeah. Well, in the center of it, it's got a black hole that's about 2 million solar masses. And when they try and measure the velocity that it's spinning, or maybe they're looking at the accretion disk around it, they're getting a speed close to the speed of light. So
whoa.
What has spun this up? I don't know, but it's spinning really fast. The other thing is it's tilted 27 degrees from edge on. So if you could crank the thing over about 27 degrees, it'd be a line.
Wow.
So it looks much better cranked like this,
yes.
where you can see the arms and the bar and that sort of thing.
Yes.
And you can see it in a moderate-sized scope. You just have to go out somewhere dark. The bigger the scope is, the more detail you'll see. When I was down in Australia, I definitely looked at it when it was high up in the sky, and it was awesome. You could, see the arms, the bar. It was really nice.
Nice. Now, just to reiterate before we move on to the river, if you are looking for this constellation, do you remember how to find it? Here, let me turn off all of the goodies here. So you walk around outside, you look around, you look east, you look southeast. Here, let me turn off the meteor showers. Hang on. Okay, so, and then you see the south, and a lot of people can spot Orion already. Okay, so what we're looking for here tonight is you're going to go south, and you're going to look a little south. You're going to look southwest, between south and southwest, and you're going to look for the circlet. And if I highlight it here, you'll be able to see it. You see it here, the circlet? This is in the whale that we covered before. Here, he looked like this with mythology. Okay, and so there's the circlet. Can you find it? Here, I'm going to turn it off again, shake it up. Tonight, it happens to be really close to Mars, but the planets move really fast, so don't rely on that too much. But you're looking for a circlet, looking for that bright star, and then you're just going to fall down south. And then do you see Fornax? Did you get it? Let me turn it on so you can see. Did you get it? The first few times I tried it, I got this bar, but that's part of the river because it's part of this big long chain. You want the two that are when you connect them together, they kind of are inside the river. You see it here? Just like that. Okay, so imagine you found it with your binoculars, with your telescope, the things we talked about already. So we're just pointing this way and going about midway and look in this area. And then we're also doing a 90-degree turn between this one and this bright star. And you're going to kind of look in this area. How'd I do, Kent? Was that about right?
Pretty good. I think I can actually physically see 1360.
Can you?
5 there on there's a little fuzzy guy right there. You see that one fuzzy object?
This one?
I think that's it, yeah.
I think
if you can blow it up. I might be wrong.
I think that one's too far south.
Oh, it's another galaxy.
That's
it's
the
too
other
far
one.
south. Okay, I'm wrong.
It's hard on computer programs, I know.
But you can see it pop up in one of those areas. In fact, there it is. It popped up.
Yeah.
It's kind of, there's a triangle of stars, and it's kind of over from
there it. Is, right there. You were real close, though. If you saw this, I'm sure you'd be happy.
But
anyway.
I could see that one. So that's really quite a bright galaxy. Also, it'd be on the chart. It'd have some sort of NGC number associated with it.
Awesome.
But
okay,
again,
great.
it doesn't look nearly as cool as 1365.
No, definitely not. All right, you ready to go jump in the river?
Yeah. Let's jump in the river.
Okay, let's do it.
And it's pronounced, I guess. It's long E, so it's Eridanus. I guess.
You did it.
Yeah.
Eridanus. Yes.
Eridanus, the river. It's an old Greek constellation. So we're getting away from the modern stuff and we're getting to the ancient stuff. And it's really long. It's up near the celestial equator, and it goes all the way down to minus 57 latitude. So you can only see it from like southern Texas and southern Florida, and it's low in the sky from those locations.
Yeah.
But it's a bright star. It's called Achenar. Yeah, I think I pronounced long A, Achenar. It means into the river in Arabic. It's the 9th brightest star in the sky with a visual magnitude of 0.45. So, it's brighter than a first magnitude. It's about 144 light years away, and it's a blue giant, about 650 times brighter than our sun. And the interesting thing about Achenar is it's spinning extremely fast, and that's flattened the shape, made the equator bulge out. It's 50% wider at the equator than it is in the polar diameter. And so it's really distorted, the actual star itself. And we had one that was similar, Altair in Aquila the Eagle, when we were talking about constellations this summer. That was another one that was spinning quickly.
Yes.
And was really distorted. But that's the interesting thing about the brightest star in, Eridanus. And so that's a neat one. want to go on to the next object there?
Yes, let's talk about it. So this one has two names.
This is the interesting one.
Okay, go ahead.
Yeah. Okay, we're going to go to Omicron 2. It's also called 40 Eridanus. It's a triple system, so there's 3 stars there. We're going to have to refer to them as A, B, and C. There you got it. And, A is a, regular orange main sequence star, so it's burning hydrogen in its core. They would call it a orange dwarf because it is burning hydrogen in its core. Our sun burning hydrogen in its core is a yellow dwarf. And B is actually the burnout core of a star. And for some reason they call it white dwarf, even though it's really small. And C is a red dwarf. It's quite small. I think it's got about 20% the mass of the sun and is only about a quarter of the diameter. But anyhow, C goes around B, and then the CB system over a long, long time goes around A. And let's see if I got some decent specs here. The A star, the orange main sequence star, is magnitude 4.5, so it's a naked eye star. You can see it if you look in the right spot. B and C, you'll need your telescope to see them. Mm-hmm. But B has about half the mass of our sun, yet it's only 1.5 times as large as the Earth. So the material that, if you have a teaspoon of that material, it would weigh a couple tons.
Wow.
It's what they call degenerate material. The the poor star has burnt through all of its fuel, and we've just got the core left. Of course, the core is enormously hot, and that's why it looks white, but it's not really a main sequence star. It's the end, of the evolutionary path. But for some reason, they called it a white dwarf in the early days, and
now,
it's kind of stuck ever since.
It kind of stick. Now, Ken, I'm curious. I'm a big Star Trek fan. So, is there any trivia I should know about this one?
Yeah. I mean, there's the A star, 40, Eridani, is actually supposed to be the star where Mr. Spock's planet of Vulcan goes around. And the interesting thing was, a few years back, they found a super Earth orbiting about the A star there, or 40 Eridanus. And the only problem is it's got a mass of greater than 8 times the mass of the Earth. And it's unfortunately too close to its star. It gets like 9 times the light that we do. Oops. So if you were on the surface, you'd get crushed by the gravity and burnt by the sun. Ooh. And so, there's, unfortunately, it is cool that they found the star around found a planet around the star that's supposed to be Mr. Spock's home.
Yeah.
But it's unfortunately not in the right area and weighs too much.
Yes. Now, how do we find it? Oh, go ahead.
Oh, I was thinking that, one thing is they might find another planet around that star. If it's further out,
That's true.
It might be livable. But right now, that super Earth is no place where you want to be. The interesting thing about the B star, or the white dwarf, is it's the easiest white dwarf to see in a small telescope. So that's, most of the white dwarfs that are fairly bright are too close, like Sirius has a white dwarf really close to it, but you can't see it because Sirius kind of burns it out.
Yeah.
It's just too bright. So this one's actually the easiest one, and you've got the little red dwarf next to it, which is really cool. So you get 2 for 1 there. The the thing about these stars, all three of them, they're only 16.5 light years from our sun. They also have the same common proper motion through the sky, which is about 4 arc seconds per year.
And by that you mean they're all moving together through the sky?
They're all moving together, and they wouldn't be doing that if they were, not part of a bound system.
Yeah.
And, also being all the same distance and moving together. Pretty much they're a binary system, but the A-B system is going to take a long, long time to, or actually it's the B/C going around A. Yeah. Takes a very long time. About, I've got a figure of 6,100 years, so that's a long, long time. It might actually be 8,000. Who knows?
It's a long time to wait for a birthday.
It is a very long time. And William Herschel actually found the A-B system. He didn't see the C star, and so he saw that pair on January 31st, 1783. And then later on, in 1851, Otto Struve found the little red dwarf and added that. And the C star goes around the B star about 248 years. And they currently have a separation of about 7.9 arc seconds. So that's still decently separated. Small scope will split them.
Yeah.
The A-B distance is about 82 arc seconds, so that's a bit more. But it is a really neat, multiple or triple system there. And so, I kind of like that one, having the easiest to see white dwarf, because those are kind of cool when you think about them.
It is. Let's show people where to find it in the night sky. How do we find this tonight?
Okay, we'd have to pull up your charts there.
How about that one?
There you got it.
Okay.
And the nice thing is you have a bullseye around. There's actually Omicron 1 and Omicron 2. Mm-hmm. We're looking at Omicron 2. There's Omicron 1 and there's Omicron 2. So you look for that pair of stars, and then you give Omicron 2 or 40 Eridanus a really good look at.
Okay, great. And so in the night sky, do you want to jump off of Rigel, or what do you want to do?
Actually, if I was doing it, I'd start out with Rigel, the foot and Orion, because that one stands out like a sore thumb, and then just kind of follow the river along. If you have a chart, use your binoculars, because you can actually see all those in your binoculars. And you get to that pair, then you put your scope on the Omicron 2 or 40, Eridanus, and you'll definitely see the A and B components. You might have to up the power a little bit to get the C component, but in my 8-inch, I could see all three of them quite easily.
Nice. Okay, great. And then did you want to talk about the NGC, the Cleopatra?
Oh, yeah. There's another nice planetary nebula not far. It's like 5 degrees below, Omicron 2, and that's NGC 1535. Real nice planetary nebula. It's called Cleopatra's Eye. There you go. I mean, yeah, it's going to take some blowing up there, but it is a really neat planetary. It's magnitude 9.4, so it's fairly bright. Got a size of 48 by 42 arc seconds, so it's small and bright, so it should show up fairly easily. The central star is magnitude 12.2. It was discovered by William Herschel on February 1st, 1785. And it can be blinked through your finder scope. I have an 8 by 50 finder scope on my 8-inch scope, and I can use an O3 filter and kind of move between my eye and the eyepiece, and this guy will pop in and out.
Nice.
So you don't.
Oh, I'm sorry. Go
ahead.
You don't
need a big scope. You just need the filter. The other thing you need to do is throw a dark cloth over your head, because those filters are so reflective. When you use them to blink, which means move it between your eye in the eyepiece and then move it back out. It's kind of fun to see. It'll pop in when you're looking through the filter, then you move away, it's gone. And you kind of go back and forth, it blinks off and on. And so
and you know what else you can do? You can ask Brian to show you Cleopatra's Eye live through his telescope right now.
Oh, cool.
What do you think, Brian?
I think that's a good idea.
I think it's a great idea. What do you guys think? Yes? While he's getting the image up for us, Brian, go ahead and share your screen, and then they'll be able to see it. Those of you who just joined us, my name's Aurora with the Central Coast Astronomical Society. This is a live view that you're seeing of Cleopatra's Eye we were just talking about. Yes, and you're welcome to become, we've gotten some questions. Can I join Central Coast Astronomy? Yes, of course you can. Just go to centralcoastastronomy.org, O-R-G, and click to join a member. It's only $20 a year for us to be able to bring these star shows to you every month. So what a deal, huh? We got a special one planned for Valentine's Day. Okay, so you've got it there, Brian. Tell us about it.
I do. Yeah, so with Cleopatra's Eye, I've actually magnified my view from my camera 400% to give you this. So if I put it back to just 100%, you could see almost like this one better. We could just see that nice fuzzy blue. And I can even pull back farther than that. This is just at 66%. But I'm really happy with how I'm able to pull out not only the central, you can see that central brighter area, and then it just nicely fades away. I wanted to point out, Rory, we had a few questions.
Oh, sure, go ahead.
When I'm sharing folks a picture, that is a live view. So what I've done is I've connected a camera straight where an eyepiece would go, right to my telescope in my backyard right now, and I'm controlling it from my office. But when Aurora shows you pictures, those are either out of Stellarium or other images that she had prepared for what we're covering.
Oh, yes. You'll be able to tell the prepared ones because Stellarium looks like a star field, but you'll be able to tell the prepared ones because it has a title at the top. This is a PowerPoint slide and an image of someone's photograph. And you'll be able to tell Brian's because, where did you go, Brian? Hang on, I've got you. Wait. Here. There you go. Because it looks like a computer screen. Do you see that?
Yes, very true.
Yes.
Right, and so one more thing I'll go ahead and point out is, well, why doesn't my image look like the one you showed?
Oh yeah, why doesn't it?
Well, first is because I don't have Hubble in my backyard. Darn. And also, most pictures that you see, like the one that's in my video background, are processed. So that picture you see behind me
Let's see you here. How do we do that?
Okay, that's a good idea. Should I spotlight me really quick?
Yes, go ahead. Spotlight you. You should.
So the picture you see behind me is actually 35 images, each 40 seconds long, stacked together and then processed in many different programs. So what I'm showing with my computer is called EAA, Electronic Assisted Astronomy. And it's an awesome way for us to share some live views for you. They're not as snazzy as what you will see in a processed image, but I really like the EAA images because those photons are fresh, as fresh as they could be coming, who knows, Kent, how far away is
let's
Cleopatra's
see,
Eye?
this one's out there. I have no idea.
Oh my gosh,
I have no idea.
I've never heard you say that.
Yeah, I mean, planetary nebula are real flaky for distances. It's got to be about over 1,000 light years, but the thing is, I've got these catalogs, and if you look at the catalogs, they reference various papers.
Yes.
And you'll have such a wide range of distances. Sometimes I'll just add them all up and average them to come up with but I mean, unless you can get the really nice overtime Hubble shots where you can see something expanding in it, so you've got, something that the rate of expansion, and you see how far it moves in milliarc seconds. You can actually calculate a distance that way, but there's only a handful that you can do that.
Okay.
And it turns out that when you compare it to the old numbers that they had for it, they're scattered all over the place.
Yes, that's true.
And so I could probably come up with a number, and most of them are all over 1,000 light years, so they're out there a ways.
Yeah.
But if they're closer, let's say under 1,000, then they start having really large sizes because they're close to us. So they actually look big.
Nice.
But I have no idea.
Whoa. Okay. Well, this is a momentous moment. I think
Yes,
it's
it
the
is.
first time I've ever heard Kent say I have no idea, and it's awesome.
So there's a lot of stuff. I could do research and come up with a number, but it would be pretty flaky.
Yeah.
I mean, with the professionals can't even come up with good numbers.
That's okay. That's all right. Well, let's show folks where to find this. Brian, we've got a number of people asking about your scope, so let's just remind everybody we're doing equipment at the end. Brian will share a picture of his telescope and setup at the end.
And I'll put a quick description in the chat right now for everybody.
Great. Okay, great. So to find this one, let me see. Let me put the little bullseye on it again. How would you find it, Kent?
Okay, we got to get back to a image of the river there.
Do you see it there?
I'm still getting Brian's.
You still are getting Brian. Oh, wait.
Yeah, Brian's 1535 or the eye of. There you go.
Did you get it?
You had it there.
I am still sharing my screen so he couldn't see it.
Okay, great. All right,
okay,
perfect.
there we got it. Beautiful image, Brian. I really like that. You can actually see color, which is cool.
Yeah.
But you can see, if you go back to the old Omicron 2 or 40 Eridanus, just drop down about 5 degrees and you get in the general area. If I was star hopping with my binoculars to get there, I would probably, go down, straight down. There's that middle star there, and we need to talk about that middle star, but you can see if you drop down about an equal distance, boom, you're in the general area. Then what I would do is I'd kind of search around with my eyepiece and, make kind of like a spiral search pattern until I come across it.
Nice.
Because I've got, I don't really have tracking or anything like that.
No. Oh, well, tell us about this middle star.
Okay, the middle star, which is called 39 Eridanus or Eridanus, is a binary star. It consists of a bright orange star and then a little white star. The bright orange star is fifth magnitude, so just barely visible. And the white star is only about 6.3 arc seconds away, and it has a magnitude of 8.5. So you're going to, need a moderate-sized scope to have a nice view of them. In fact, you got it there. That's really cool. There's enough separation where you can actually see it there.
Yeah.
And
nice.
so,
okay, great.
It's just a nice, since we're looking at, Cleopatra's eye and we're looking at Omicron 2, it's right there. It's like a freebie.
It is. So, and I think that's all we were going to do in this constellation, right?
So, we covered, there's a lot of stuff to cover, but these are up high enough so we can see them from our part of the world.
Nice. Okay, well, let's do a quick review. So we're walking outside. We noticed the moon is setting. We took a look at that. We're looking southwest. Do you guys see do I have the circlet on there? Yeah. Do you see the circlet? Okay, so we're looking for him. Do you see it now? We're going to look up here. And we're going to drop down, and we are looking for 2 stars. Do you see them there? This would be Fornax. We go this way to see the first object we talked about, and a 90-degree angle to see the second with the barred galaxy, which was in here. And then over to see the objects we just talked about, Omicron, 1, 2, NGC, I have to look. I'm not like Kent. 1535. We started with Rigel. And then we simply moved over until we saw this star pairing. Let's see, let's turn on the constellations.
That's the Omicron 1 and Omicron 2.
And then
Eridanus.
that's it. And then we're going to look in this area here. I'll turn it back off. So we were on Rigel, and we just kind of go straight here.
There's a way to find it. Yeah, there's more than one way to skin a cat.
Oh,
when it
totally.
comes to star hopping.
And you'll find these two, and then we're going to drop down. This is the binary we were just talking about. And then if you go a little further, you'll see that the Cleopatra's Eye that Brian showed you down in this area. Whew, how'd you guys do?
And the one thing is, if you're young, that color will pop out pretty easily. As you get older, the colors don't pop out as well.
Oh, no.
It's just one of those things. It's funny with planetary nebula.
Yeah.
I'm actually one of these people that see most of them as outright green. Some people see it as blue. But when I ask children, what do they see? They see blue-green or turquoise.
Oh, wow.
And that's actually that's the right color. If you look at a frequency, color diagram, it turns out that turquoise is really where that frequency of that light hits.
Wow.
And so
cool.
I get the feeling as you get older, you may kind of drift to the blue or drift to the green, but it just doesn't look the same as when you're young.
Yeah, I could definitely see that. All right, should we go to my favorite area of the sky here? This is my personal favorite, so let's check it out.
Oh, okay.
All right.
You want to go for Taurus?
Yes. Can you tell I was born in May? Okay, so here we go. We have Orion, and belt of Orion points right to the area we're going to be talking about in this area. Let me turn on the constellation so you could see it better. Taurus the Bull, what do you want to tell us about it?
Okay, first we've got the brightest star in there, which is, Aldebaran is the brightest star, but also you can see the horns on there. And one horn, the northern horn there, is Beta, and it's kind of shared with Auriga. It just slipped in under the 1930 rules for constellation boundaries, but it's just on the Taurus side. And then the other horn is called Zeta. And also, you can this is like a quick overview.
Yeah.
You can see up above there, just got pushed out at the top, is the Pleiades.
Yes.
Right there. But what we're going to talk about is a different cluster right near Aldebaran, which is the Hades. But first we'll hit Aldebaran.
Okay.
And Aldebaran is a star that its name means the follower in Arabic, and it follows the Pleiades. When the Pleiades comes up, later on, Aldebaran comes up. And so that's, that goes way back. And it's also shown as the Eye of the Bull. In a lot of the constellations going way back, they show the Eye of the Bull as being Aldebaran. Also, there's a legend involved in this one. And it's kind of funny, is Zeus, who was king of the gods, he had a wife named Hera. But also, Zeus had a bunch of girlfriends.
Uh-oh.
And he would transfer into different, shapes to, kind of confuse Hera so he wouldn't get in trouble.
Oh, no.
And he transformed himself into a bull, and I think he was swimming across that area from Europe to Turkey, Hellespont or something like that.
Okay.
And for some reason that got put into the sky as a constellation, and so you only see half the bull, and the hindquarters are buried in the water. But you do get his head and his horns for the most part. And so that's the legend that I could find about Taurus the Bull.
Wow, nice.
And Aldebaran itself is a bright star. It's the 13th brightest star in the sky, magnitude 0.86. It's also an orange giant. If you look up there, you can see it has kind of an orange tint to it. It's 40 times the diameter of our sun, about 125 times brighter, and it's only 68 light years from us, so it's fairly near.
Nice.
Does that make sense?
That's perfect. Yep, it totally does. Do you want to talk, you want to go up to M45 next, or do you want to
Well, actually, right next to, even though it's not part of it, we've got the Hades.
Oh, yes.
Which is really a pretty binocular. I mean, if you got binoculars, find Aldebaran and look around there. There's a lot of bright stars. It's an open cluster. It's the second nearest open cluster to our sun. It's only about 140 light years distance. And it can be seen, roughly as a V shape, kind of pointing at Aldebaran. Aldebaran is half the distance, so it's a foreground star. But also the Hades forms a nucleus of a larger group referred to as a Taurus moving group, which seems to be moving as a group towards a point near Betelgeuse in Orion. And there's about 25 stars between magnitude 3.3 and 6.0. So there's a lot of them in there, a lot of fainter stars also. So it's kind of a nice and easy group. You know, you go for Aldebaran, and then boom, you've got an open cluster there.
Nice. Oh, perfect.
And then I've got another little open cluster not far away from Aldebaran. It's called NGC 1647. It's roughly 3 degrees northeast from Aldebaran. It's magnitude 6.2, so it's fairly bright. It's about 40 arc minutes in diameter, so it's slightly larger than a full moon. And it's about 1,700 light years distant. And you can easily find it just by sweeping around with 750 binoculars. There's about 200 stars in this little cluster, so they're kind of packed in there, and your image you're showing there shows it really nicely. Very easy to find in binoculars. At least I didn't have any trouble. As long as you got a dark area, it'll show up. William Herschel discovered this little cluster on February 15th, 1784. So since it was a binocular object, I figured it was worth throwing in there.
Absolutely. That's a really cool one. I haven't seen that one in binoculars, but it's so easy. All you have to do is find this V, and it's like right there. You just flip the V over.
Yeah, it's just right over there. It's, you know, it's not nearly as bright as those guys, but it definitely shows up in your binoculars. And if you've got a small telescope, then flip around. You know, the two go together. You use your binoculars to get into the general area to know where you're going. Then you swing your telescope around, because now you know where you got to go. And then you get the really nice view with the scope.
Yes. Do you want to talk about the M45?
Actually, I was figuring we'd hit the M1 supernova remnant.
I forgot about M1. Yes, let me put
remember the horns on the bowl? The southern horn is called Zeta. And you just kind of go up from Zeta, and the Crab Nebula is there, and that's Messier 1, so that's the very first Messier object. Charles Messier came across it, and he's going like, it looks like a comet, it's fuzzy, but it didn't move. So this was like number 1 on his nuisance list, and you can see this is actually, I think it's the only supernova remnant in the Messier list. And you can see all the filaments going out from that. So this is a massive star that just blew to smithereens. And the interesting thing is, it blew up on July 4th, 1054 AD.
Wow.
So, almost 1,000 years ago, you had this new star appear in the sky. And it was bright. It was around magnitude -4 or brighter. It was visible even in daylight. The Chinese astronomers were able to observe it from July 4th, 1054, all the way to April 17th, 1056.
Whoa.
So not quite 2 years, but over a year. They were able to observe it before it faded from view. And that's the beginning of the crab. What we're seeing today is a remnant from that explosion. and it's about 1.1 degrees northwest of Zeta, which is the southern horn of the bull. It has a magnitude of 8.4. It's about 6 arc seconds by 4 arc seconds, and roughly about 6,200 light years away. It was found by John Bevis originally in 1731. So he actually caught it before Messier, but Messier probably wasn't aware of it at the time.
I see.
And in the center of the Crab Nebula is something interesting. There's a neutron star that's spinning rapidly. They call it a pulsar. And I think it pulses like 30 times a second, something like that.
It does.
And it turns out the name, the Crab Nebula, came from Lord Rose. He had this massive, actually it was a metal mirror, 60-inch telescope in Ireland, and the shape of him reminded him of a crab. So he gave it the nickname Crab Nebula, and it stuck.
I have the sound here. Let me see. Doesn't that sound terrible? Were you able to hear it?
I don't hear anything.
You didn't hear it. Okay. It sounded like a sort of a sound.
The cool thing is they've been able, using the Hubble, and the Hubble's been up there for enough years, they've been able to see some arcs near the pulsar moving. And that means they can get a really good distance on the pulsar in there. So, that 6,200 light years is probably pretty good.
Yeah, that's awesome.
All
right,
which is in fact.
Yeah, go ahead.
In fact, there's like a motion picture of the pulsar in the Crab Nebula they took over the years, and you can actually see the pulse going through the Crab Nebula.
Really?
I don't know if you've ever seen that.
No.
I think it was on the Astronomy Picture of the Day one time as maybe a little YouTube video or something.
Okay.
But I thought that was pretty cool. In my 8-inch scope, it just looks like a little blob S shape. And if you have 1050 binoculars under dark, steady skies, you can probably just pull it in as a fuzzy blob. So you need a good size scope to start seeing anything decent. And also it's weird, but filters tend to help. I get a little bit of different enhancement with like a 2-inch O3 filter on it. So, strange but true.
Cool. Well, let's.
I guess we can get it to M45 now.
Yes, Brian has a surprise for everybody. He's got M45 in his scope. So why don't we show people where it is, and then we can flip over to Brian.
Okay.
Okay. So here we go. M45, super easy to find. What did you think it was? Most people make this mistake.
Yeah, I mean, when I was a kid, before I learned the constellations, I thought that was the Little Dipper because it looks like a short-handled dipper with the naked eye. And so I called it a Little Dipper until I got a book on constellations and taught myself what it really is the Pleiades. It's also called the Seven Sisters. There's the right book, yeah.
Yes.
And it's a beautiful naked eye, open cluster, easy to be seen with the naked eye, and it has a visual magnitude of 1.5, so that's pretty darn good. It's about 425 light years distance, and the age of it is about 100 million years, and it's a beautiful object in binoculars. Really looks nice. That blue reflection nebula that you see around it isn't tied in with the birth of the Pleiades. It just happens that the Pleiades is moving through a dust cloud, and the stars of the Pleiades are lighting up the dust or reflecting the light off the dust, and you get this, this blue nebula around it, which is just reflected light. And so it doesn't. In the old days, they thought it was part of the cloud where the Pleiades was born, and now we realize that it's just moving through a random dust cloud out there.
Nice. All right, Brian, you ready?
You betcha.
Dun, da, da, da. There you are.
All right, you just share the right screen here.
Sure.
Here we go. All right, and here you go.
Whoa.
This is
pretty.
a live view of the Pleiades. And one of the amazing things with this object is that there's actually cloud of dust around
I
these
see
stars,
it.
right?
I
I
totally
can see
see
it.
it.
It's faint, but it's there.
Yes.
And
And
you see also how much it covers. It's actually good sized.
Yeah.
yes, this is a very fun object to look at no matter what you're using, just your eyes, binoculars, or even telescope. It has something to offer, I think, for everybody.
Nice. Yeah, and we'll actually talk about what binoculars we recommend for doing this kind of looking, so you'll be able to see it. Binoculars are better than telescopes for M45. Is that right, Kent?
Oh, yeah, definitely. I mean, for the appreciation of the object. You know, a telescope, you can only get like one, unless you've got like a really small telescope will help because you have a wider field.
Yeah.
And this is a wide field object, you know. It covers quite a few degrees out there.
Yeah, it
And
does.
so, but, you know, binoculars are great. I mean, it really looks pretty in binoculars. Your 100-millimeter binoculars, it probably looks fantastic
Oh,
in those.
it's amazing. I'm actually going to do that as soon as we're done. I know we've got people saying, when are you going to talk about equipment? So let's keep going. We have one more little bit of stuff to do. Thank you, Brian. That was an awesome
You're
picture.
very welcome.
Yeah, neat picture, Brian. That's
Nice.
beautiful.
Thank you.
So just real quick to review this part of the sky, we have Orion here. Most people can recognize that. The belt stars are pointing towards the V. V is where we saw the open clusters that Kent was talking about and that super bright star, Aldebaran. And then if you just keep going, you'll see the Pleiades, M45, that we just saw through Brian's scope. So it's a really easy set of things to see and through the night sky. Are you ready to talk about a chariot?
Yeah, let's talk about the charioteer.
Okay, let's do it.
You know, what they call Auriga, which
Yes.
again is another old Greek constellation. You can see it kind of looks like a pentagon there for the actual rough shape of it. And, you know, it's really weird. It's got a couple of old things associated with it. It's a guy driving a chariot, so it's tied with the gentleman that created the first 4-horse chariot, probably used in war, that sort of thing. But the other strange thing is that he's holding a she-goat, and then there's 2 young little goats, which are called the kids. And if you look, there's like a triangle of stars below Capella there. And those are the kids, and actually Capella's called the goat star, which is for the she-goat. And that comes, they think, maybe from an older constellation. There's no really good records about it, but it's strange that this guy's driving a chariot and he's hauling goats around.
Maybe it was a thing back then.
Yeah, who knows, you know.
2 goats, my daughter. No, okay.
You never know about, you know, what the Greeks were up to. But definitely a strange thing. You know, the goat thing may go way, way back. It may go back to Babylonia or something like that. But that's what we've got. So, and it's stuck. I mean, we've got it for now on.
Nice. All right. So, in the charioteer, is it Auriga or Auriga? Would you guess, or does it?
I call it Auriga.
Auriga.
You know.
Okay.
Who knows?
So, what kind of star? I see it says the goat star.
Yeah, that's the brightest star in Auriga. It's called Capella.
Okay.
And it's actually a spectroscopic binary. You can't see it in a telescope, but if you hook a spectrograph to the telescope, the spectral lines shift back and forth.
Oh, wow.
And that means it's actually a double star. And, you know, Capella itself has a magnitude of, 0.08. So it's almost, 0 magnitude. It's the 6th brightest star in the sky. It's about 41 light years away, and, you know, as is, it's about 133 times brighter than our sun. But in reality, Capella consists of a pair of yellow giants that are really close to each other. They're like, I think it's about 70 million light years. I mean, not light years, 70 million miles apart
Okay.
of these two yellow giants. So that's about the distance from roughly our sun to Venus. So you've got these two massive stars. One has about 2.7 solar masses and is about 14 times the diameter of our sun. The other is 2.6 solar masses and 11 times the diameter of our sun. So they're pretty close to each other. They orbit about a common center of gravity about every 104 days. So
Wow.
you've got two great big bright stars right next to each other, spinning
Nice.
about.
Cool.
Unfortunately, we can't visually see it. You can only, infer it from a spectroscope
Okay.
by looking at the lines there. But anyhow, that's the brightest star in Auriga.
Perfect. And now we just have 3 or 4 more objects, but they're all really close together. Well,
Yeah,
yes.
these are neat. The first one is M37, really rich open cluster. I don't know if Brian can get that in his telescope.
Does. He actually is centering it right now. Why don't you tell us
But
about it, and then we'll go to Brian.
It is a beautiful, you can pick it up in binoculars, but in a telescope, it really looks nice. It's a rich open cluster. Its magnitude 5.6, has a diameter about 25 arc minutes. It's about 4,500 light years away, and it was discovered by this guy Holdernia in 1654, so way before Messier found it. It has about 2,000 member stars in it. It's about 500 million years old, so it's 500 million years old.
Wow, that's amazing. That's awesome. And let's see, Brian has something to show us. So go ahead, Brian. He's got M37.
I do.
All right.
Yes.
You are just booking tonight. I only thought you'd share one or two.
Yeah, my telescope's
There
doing all
it
the
is.
work.
Nice.
Oh, beautiful, Brian.
Nice.
You can
Yeah,
see how rich, how many stars are in
It
that
is.
guy.
And this is another fun one that I've had with binoculars and with my 10-inch telescope. And just to kind of show you, this is also, it's a beautiful view even if you're not zooming in so much.
Mm-hmm.
So
Yeah,
here's our-
it's really nice in binoculars. It's easy to pick up.
Yeah. So let's show folks where to find it. When you're done, Brian. When you're done. Take
Okay,
your
the
time.
one thing about M37 is it's not inside of the pentagram.
Right.
It's actually outside of the pentagram, but just barely outside
barely.
the pentagram.
Mm-hmm.
Okay, I'll go ahead and stop the share now.
Okay, great. All
Hey,
right.
thank you, Brian. That
Thanks,
was really
Brian.
nice.
That was great. Okay, great. And so
In
we've
fact,
got
you can see it there, how one side of the Pentagon or whatever,
Okay.
and it's right outside of it. So to find it, you just find that one side in your binoculars, and you can't miss it because you can actually see this little fuzzy spot.
You can. So here's that V we talked about before with the Hyades and here.
Aldebaran, yeah.
Aldebaran, here's the Pleiades, here's Orion. Now we're going this way. And so it's kind of like the top of the ice cream cone. So if the Hyades, this triangle's like the cone bit here. It's not really the ice cream cone. That's another constellation, I know. But it's kind of like the pentagon, hexagon thing up here. And you're looking right in this area. Here's Capella, the goat star. So it's across. And then you want to bop us over to the next one?
Well, one thing I want to
M36.
do is talk about this Holdernia guy.
Oh, yeah. Why is he important to know about?
Yeah, Holdernia, he was a Sicilian astronomer.
Mm-hmm.
He lived from 1597 to 1660, so he was back in the Galilean days. So they just had really small little refractors that they used. And he published a paper in 1654 containing 46 nebulous objects, and at least 10 of them are original discoveries of really deep sky objects.
Mm-hmm.
The thing was, his paper was lost until 1984. No one had, dug it up and then went, man, this guy found this stuff way before Messier.
Wow, that's amazing.
And so Holdernia is, now they're giving him credit, but It was just the paper didn't get widely separate, dispersed out there where other people could read it, probably in Italian anyhow. And so, but it must have been sitting in an archive somewhere, and then someone came along and pulled it out and got a real shock that. And stuff like this happens all the time in astronomy. You'd be surprised when they start looking at original papers or digging around.
That's true.
Where you thought someone discovered a deep sky object, you'll find a paper where someone found it 50 years before.
or hundreds.
yeah. I mean, it's as you the miracle thing is that the paper survived all this time, because you're talking, 1654. That's a long time. That's 350 years ago.
A long time.
Yeah, and the paper survived. It wasn't burned up or thrown away. It survived all that time.
Awesome.
But
so
anyhow, that's who Eridanus is. You want to go on to the next open cluster?
I was just going to mention to everyone, thanks so much for joining us. This is Aurora and Brian and Kent, and all the astronomers from CCAS are busy answering all the questions, so thank you. We're going to shoot through these last really quick because they're really close together, so just take a couple of quick notes as to where they are. You ready, Kent? Here we go.
Okay, let's hit M36.
Here's M36.
It's another little open cluster. It's just inside the pentagram, and it has a visual magnitude of 6.0, about 12 arc seconds across. It's 4,300 light years away, and like M37, M36 was also discovered by Eridanus in 1654. Nice. And this is a young cluster. It's only 30 million years old. It's visible in 750 binoculars. And also, M36 is how the Pleiades would look if you could move the Pleiades 10 times further away. So,
Oh, that's cool.
That shows you what if you grab the Pleiades and shove it 10 times further out, it would look roughly like M36 looks like.
Yeah.
And, where M37 is 500 million years old, this is only 30 million years old. So.
Yes.
Fairly young cluster in comparison.
Yes, and then right next door is
M38. And this one it's another open cluster, has a visual magnitude of 6.4. It's about 15 arc seconds across, and it's 3,500 light years away. It also was discovered by Eridanus in 1654. And it's about 175 million years old. It's also visible in 750 binoculars. So you can actually hit 37, 36, and 38 kind of goes a line up into Auriga.
Right here, here, and here.
And there.
Yep. And then we have the oddball.
Yep, 1907.
Let me get that one in the target. Okay, go ahead.
Yeah, 1907 is an open cluster. It's small, compact, only about 40 stars, and it's only 30 arc minutes, so it's about a full moon diameter southwest of M38, so it's not that far away.
Yeah, so M38 is the one on the right, and 1907
yeah, M38
is
the one on the right, and then 1907 or NGC 1907. The problem is there's so many stars in that area that a lot of the photographs kind of make it disappear because there's so many stars popping out. So you have to go for shorter exposures to make it pop out. But it's of an age about 350 million years old, and it's about 4,300 light years distant. So it's about 800 light years further away than M38.
So we're looking, here's that first one we saw, M37, and then M36, M38, and NGC 1907. So they're all
1907.
All in this area.
So you
right
get
here.
kind of 2 for 1 with M38.
You totally do.
And we were talking about how it's similar to Messier 35 in Gemini.
Yes,
because
that's
it had had a little open cluster right next
I
to
have
it.
a picture of that. Here it is.
The 2-for-1s are nice, you know.
Yes. Here we go. Here's the one
When
in
you go
Gemini.
through all the trouble there, you can see it. You can see the nice Messier 35.
This one's not in the handout. Kent just mentioned this yesterday, so I quickly put a slide together. So make a note if you'd like to see these two. Notice the color difference.
Yeah, which means the yellow one's got to be older.
Yes.
The blue stars have died away, where Messier 35 still has blue stars in it.
That's awesome. All right, I know we ran a little bit over time. Kent, there was an asteroid that one of our members, Peter Bressler, this is his home observatory. Did you guys see it in here? Did you know about this one, Kent? Do you see this little dot?
That's a planetary nebula. I think it's a Medusa nebula.
Yes. I'll see, I have information here. He was shooting Able 21.
Okay, yeah, that's the Medusa nebula. It's like a one-sided planetary nebula.
So here's the little dot that's moving from shot to
Oh,
shot.
okay, that's the asteroid.
Yeah, so he caught that one. It's an S-type asteroid, so it's going to be brighter, S for silicon. And so you can kind of see it move through there. Isn't that cute?
That's cool.
Isn't that neat? So, and
yeah,
Brian, go ahead.
You know, that Medusa nebula is kind of neat because I've seen it in a really small telescope, like a 4-inch little reflector. I've actually managed to see it. I had the cradle in my lap and use an O3 filter on it, but I could actually pull it in.
Wow.
So it's relatively has a good O3 response.
That's awesome. See, this is what I mean. You can show Kent a picture of anything and he's like, oh yeah, I've seen that. Oh yeah, that's right. Oh, well, this is a weird one. So thank you, Kent. You're amazing. Hey, we've got one more for you. We're not going to tell you what this is, but most of you will recognize it. Brian just put it in the telescope. I don't have a slide on it. We're not covering it, but I wanted to share it with you. Brian, are you ready?
Oh, wow.
There, oh,
that's pretty.
You're the only one who can see it. There we go. What do you guys think? Does anybody know what this is? Don't say it yet, Kent. If you recognize it, go ahead and put it in the comments right now if you think you know what this is or what constellation, I should say, and what constellation it's in. You can see this with binoculars tonight. And we kind of just brushed on it. Don't say it yet, Kent. And let's see if other folks are getting this one. That's a beautiful image there, Brian. Your seeing is really good tonight. Let's see. Brian, did you want to talk about this one at all? Looks like folks are bringing it in. Yes? All right, we are going to talk about equipment here in just a second. For some reason, Brian, you're muted.
Oh, yeah.
There you
I was
are.
muted. Yes, we got it. I think Chris was the first person. It is the constellation Orion, and this is indeed the great nebula in Orion, M42.
Yes, and if you want to know where that is, you are going to go find Orion. There he is. Let me zoom in on him. There you go. You can actually see it right there. So look for his belt stars, look for his sword, and it's that middle star right in there, or middle bright patch. When you look in binoculars, it is not going to look like Brian's amazing view, is it, Kent? What's it going to look like?
Nope, it'll look like a little fuzzy area. The cool thing is Brian's, I think, has the entire sword there. You know, there's 3 stars that make up the sword of Orion.
Yes.
And, you know, I usually see them as vertically. This is horizontal, but, you know, it looks like what looks like 3 stars. You see there's more stars than that, but it actually looks like 3 stars hanging off the belt there. And that's the sword. And the Orion Nebula is right in the center of the sword.
Nice. Perfect. Okay, great. Oh, you got a lot of people who definitely like that. Where's the horse head? People want to know where the horse head is.
Yes, it's behind me in my picture. Well, so we will, I think we'll say stay tuned for a future show, and we'll show you the horse head and the flame live. They are more dim, but I can bring them up.
That's awesome. Something to look forward to,
episode,
huh?
yes.
Something tantalizing. All right. Well, Kent, thank you so much. If you want to hang on for a couple of quick questions, Kent, we would love it. But,
sure.
That would be great. Brian, you've gotten a number of questions. I think you've gotten buried. Do you have one or two. Let's see, I've got a whole bunch of them here too.
So I would start with, someone actually asked the question, is there a certain galaxy that's rather unique radio wise?
Oh yeah, there's actually it's kind of funny with radio galaxies. There's one that's really cool in Centaurus. They call Centaurus A, which is the biggest radio source, and I think it's 5128, but it's actually an elliptical galaxy that had a spiral galaxy kind of collide right in the center of it, and it has big radio globes going out from it. But they usually give an A designation to the strongest radio source. There you can see the remnants of the spiral galaxy there. Elliptical galaxies aren't supposed to have dust lanes, and that one was driving them nuts. But it's called Centaurus A from the radio survey, and it's got great big radio lobes. They think there's a big black hole in the center, so you've got plenty of fuel for it with this spiral galaxy getting swallowed by this big elliptical galaxy. And so that's one really neat radio galaxy. Usually they have the constellation and then they give an A designation for some galaxy that has something really bad going on, like this one in Centaurus. But that's one right off the top of my head that I can give you a number for.
Oh, that's perfect. There was another question that was similar. Here, I've lost my screen. Hang on. Here we go. For those of you who've joined us, yes, you can join Central Coast Astronomy. Just go to Central Coast Astronomy and click join. It's $20 for a year. We've got a number of people that say, I want to join. And that enables us, I don't know if you noticed, there's no ads on this. So that enables us to bring this show to you. So thank you so much. You can join no matter where you are in the world. The question was, are those images live, Brian? Do you want to talk about that?
Yes. Yeah, the images that I shared are live.
Yes.
And the images that Aurora shared were either from the program Stellarium, which is available at stellarium.org, or slides that she put together from various sources. And coming up soon, we'll start talking equipment, and I'll bring up a picture and tell you a little bit more about my setup.
Perfect.
I have a couple other questions that I could bring up if you like.
Yes, please do.
So another question, and I'll put this one to Kent, is could you explain a little bit about what arc seconds are? You talked about how we would see separation between objects as a pair of distance.
Arc seconds are taken off of the distance from the South Pole to the North Pole. And basically, if you go an entire circle around the poles, that's 360 degrees. We usually talk about in declination. And so basically, 1 degree is equal to 60 minutes. And then 60 minutes is equal to 60 seconds. And that's what they mean by a second of arc. So it's 1 times 60 times 60. So it's 1/3,600 of a full circle. So it's a very minute thing. You've probably seen those plastic protractors. That does 180 degrees. And some people have a circular one. There it is. That arc is 180 degrees of arc. You put two of them together, you got 360 degrees of arc. So basically you got degrees. Well, each degree is broken up into 60 minutes. And then it's kind of like our clock when you think of hours, minutes, and seconds, where you basically have 1 hour is composed of 60 minutes, and then a minute is composed of 60 seconds. Mm-hmm. With arc, you work with degrees. 1 degree has 60 minutes of arc in it, and then each minute of arc has 60 arc seconds. When you're working with, so it's actual distance on the celestial sky. Mm-hmm. And if you're talking about the Hubble, you're talking about milliarc seconds, sometimes 1/1000th of an arc second, when trying to separate things. can't do that from the ground very easily because of the atmosphere.
No.
But when you're above the atmosphere, you can get somewhere in the ballpark on some of this stuff.
Yeah, and typically,
does that make sense? Or?
Yes. That's great. If Kent will say something like, and there is a 30 arc-second degree of separation between the two, he's letting you know that you'll be able to split that using binoculars. So if he had said something, a much larger number, then you would be, so if it's a smaller number, they're going to be closer together, and if it's a larger number, they're going to be further apart.
Yeah, one real easy thing is think of the moon. When you look at the moon, it's 30 arc minutes. From one end for a full moon, it's 30 arc minutes. So that works out to 1,800 arc seconds. And everyone knows the moon, so that at least gives you, it's roughly half a degree. And also our sun is roughly half a degree, depending on where we are in our orbit around our sun. And so during a total solar eclipse, you actually have the moon cover the sun, because they're almost the same size.
Nice. Perfect. Awesome. Thank you. Well, Brian, let's go ahead and hop over to some of our questions about astronomy equipment.
Sure.
I was going to give a kudos out to Lee Coombs for designing the CCAS shirts. He took the picture on the back. Lee Coombs is one of the members of CCAS at Central Coast Astronomical Society, and we put one of his pictures on the back. He's actually been published in more than 1,000 times in places like Sky and Telescope and Astronomy Magazine and books. He was in this book the other day. I was looking through it and I saw a couple pictures of his in here. So if you are interested in learning more, if you like this, the book that Kent used when he was teaching himself astronomy, drum roll please. Go ahead, Kent.
Yeah, The Stars by H.A. Ray. It's still in print.
I know.
I think it came out in 52. And it looks like it's made for maybe a first grader, but that's basically what you need when you're learning, especially when you're teaching yourself. It's really nice to have simple drawings.
Yes. Very much.
Yeah.
And for those of you who would like a little bit more information on the moon, this is a good resource as well. You can take a screenshot if you like. There's a lot of books on the moon. I don't know if you can see it, but I have a National Geographic Earth or moon map. It's got both sides on it, which is cool. And even though you can't use one of the sides, it's okay. You can take a look at them there. Another good book, two good books. This is the one I learned from, which I don't think I've ever mentioned before. This is a newer edition. Mine's all beat up right now, but Night Watch. And this one's by Terrence Dickinson. Look at the binding on this. Isn't this useful? Kent, check this out. It's spiral bound on the inside.
Oh, okay, spiral bound.
Finally.
Yeah, that's always nice.
So this is a really good one to also get started with. And here's my last one, Touring the Universe with Binoculars. Tom Fry had mentioned this one before as a good resource.
That's another good one. One thing I want to do is make a plug for National Geographic.
Yes.
Because they have lots of neat maps and articles. And it's a relatively cheap magazine if you subscribe. My grandfather started subscribing in 1934. I have every issue from 1928 to now for National Geographic.
Oh my goodness. Have you read them?
Oh yeah. I went through all of them as a kid. I mean, mainly I liked the pictures when I was young.
That's awesome.
But they've got neat maps. They always have maps in them. And the astronomy maps are great. I mean, I've stuck a lot of them on my walls during the many years.
Kent, that's almost 100 years worth of magazines.
Oh yeah. I mean, it's a lot of them are stuck underneath the stairs right now.
Oh my
Just because
goodness.
they weigh a ton. Let me tell you, but they're National Geographic is just a nice magazine. It's a really good paper. Great photography, good articles.
You want to know where Kent learned it all? Now we know.
Yeah.
The other two we can put a plug in for. If you are interested in astronomy at all, you should be subscribing to one, if not both. So they have star charts and maps. They have the star chart of the month is included for Sky and Telescope. I personally like is it Astronomy that has the Jupiter one? Yes. I like the
Oh
one
yeah, show you where the moons are
where the
around
moons are
Jupiter.
for Jupiter. So
And
yeah.
they tell you where the planets are. Yeah, I mean, you can't beat. You should
Awesome.
subscribe if you're interested in one or the other or both.
Yes. Okay, and so moving on. This is the question everybody wants to know. What do I buy? Oh, I love astronomy. That was fantastic. I follow it along. Honestly, don't buy one of these. This is a paperweight. So the only thing this is good for is looking at the moon, and that's only if you're really good. So don't buy a cheap telescope. It's better used off as a doorstop, or even just better off on the shelf if it says Costco or Walmart or anything like that. Walk away. The thing you want to buy is a set of binoculars. Now these are 7x50s. And so, Kent, what does the 7x50 mean?
Okay, 7 is the magnification. 50 is the millimeters of the front lens that you see there.
Okay.
So the bigger that number is, the more light you pull in.
Right.
So those big ones behind you, I think, are 100 millimeters.
Wait, let me look at look at the size of my head. Look at this.
So, I mean, you need a tripod, but things look really beautiful through a.
They do.
And actually, the ultimate is get the old Japanese battleship binoculars that are 125 millimeters and have rotating eyepieces.
Oh my goodness.
And, those you need a really big tripod, but fantastic views through something like that.
So the other thing I want to point out over here, I actually have, so these are $35 from Celestron. They're called Cometrons. Great for stargazing, great for beginners, super inexpensive. If kids drop them, you're not too worried because they aren't that expensive compared to other astronomical equipment. The ones I have on that Paragon, do you see it's a parallelogram looking thing here? These are about $150. These are my favorite. They are ultra views from Orion, and they are 10x50s. So they're magnifying a little bit more, but still got the same the same lens on the end where the light comes in. And I like this.
Yeah. Another cheap place is Big Five. You can get binoculars there.
Yes, you can.
Almost everyone knows where a Big Five is located.
Definitely.
And so, if you want to just drive there and pull out a pair of binoculars, they have 1050s and 750s, I believe.
Yes. So, and yeah, when you look through them, just make sure you can see things like trees, birds. They don't rattle, they don't have scratches, they haven't been dropped, and then you're good to go. And honestly, you want to get these before you even think about a telescope, because telescopes are useless if you don't know where to point them. Even the fancy one I have behind me, where is it? This one has a brain on it. It has tracking, and it's still hard to use. Yeah, you can plug it in, but it's going to have other problems. So I wouldn't just run out and get, this is an 8-inch telescope, which means it's 8 inches across. That's the size of the main mirror in the back. This design is much shorter. I don't know if you can tell, it's not that long. It's like this long. If you look in the other, where did it go? If you look at the other one, that tube is a whole lot longer. That's also an 8-inch, but it has less stuff inside, so it's lighter. And for example, this is called a Newtonian. It's a reflecting telescope, and it's the same one that I showed you at the beginning that Kent had here, only his is a lot bigger. So here, let me see if I can see it. There we go. This is a Newtonian as well, so the light's going to come in, and the mirror is here, bounces off a little mirror that's at a diagonal so you can see. And here, let me show you the other one. Okay, this one, the light comes in, bounces around a few times, and then the eyepiece is in the back. And people like these because they're lighter. They're really good all-purpose telescopes, and so you would plug in your eyepiece, or if you're doing astrophotography, you could put that in there as well. What you get depends on a few different things. So if you've learned the night sky and you've got your binoculars, you've done that for a while, you're comfortable, you're ready to take the next step. Usually the question is, what do I get? And our answer is nothing yet. Go to a star party, especially I know now there aren't that many going on, but when they happen again, and then look around and try all the telescopes and see which one you like best, which ones are easiest to operate, which ones work best for your location, and also, what do you want to look at? That will determine also what you're looking at. So for example, Brian's telescope looks very different than mine. These are just, I want to go outside and look through the telescope. I'm not doing anything special. I just want an good all-purpose telescope. You know, I want to look at the moon. I want to look at the planets. I want to look at some deep sky stuff. Really good all-purpose telescope. A few planetary nebulas now and then. And actually, that's the one that Kent had. Kent has this one. So very similar to the one that's behind me, right there. So Brian, do you want to talk about yours? You want to show everybody? They've all been waiting.
Absolutely.
Okay.
Yes, indeed. So this is my telescope setup that is running in the backyard right now. This is a 120 millimeter refractor telescope. So light enters from here and then is refracted through a set of lenses and then comes out here. An eyepiece can go right where my camera is. 120 millimeters was just between 4 and 5 inches is the aperture or the opening where light enters. And so this is the camera setup. By the way, the telescope is an Orion AstroView 120 ST. And then the camera is from a company called ZWO. This is the ASI 2600 MC Pro. And this has a very similar chip that's in some of the professional Canon digital SLR cameras. The catch is that there's no mirror to flip, like many of those cameras, and cameras for day-to-day photography actually have filters that block certain wavelengths of light, like infrared, which makes astrophotographers very grumpy when we can't catch any kind of light wavelength we might want to catch. So when this kind of a camera, it's specifically designed to hook up straight to a telescope, or I can actually put camera lenses straight on it. And when you're using photography, or I should say astrophotography, you need to keep your chip cool. Otherwise, noise from the electronics will start to bleed into your pictures. So this actually has a built-in fan and cools itself down. And I have this running at -10 degrees Celsius tonight.
Whoa.
Yeah. And so the mount, or the actual telescope tripod, this is called a Celestron Advanced VX. And this has what's called a clock drive in it, plus more. Clock drive is used so that it tracks with the sky as the Earth rotates. So if you're ever wondering where north is in relation to my house, you can tell. If I start from the back and draw right up this axis and keep on going, that is pointing straight at the North Star. And this mount, actually, I added a little camera that I put right on that axis, and using a special program, I make sure I'm spot on centered. That helps me make sure that what I'm showing you in my camera image stays where it's supposed to be.
Nice.
So while I'm here, Aurora, I had a question that came over about aligning your finder scope with your telescope.
Oh, yes.
So I thought I might do that while I had this up on the screen.
Yeah, good idea. Go for it.
So this being the main telescope, and what I'm going to share with you is true whether you have a refractor or a reflector telescope. The finder I have on here would be this other tube right up here. This is basically a smaller telescope that gives you a much wider view of the sky. It's almost like we might call it a monocular. This is very similar. This is actually a 10 by 50 finder, just like the binoculars would be. You notice I have a little camera here for other uses I won't worry about. But if you need to align your finder scope with your telescope, best thing to do, frankly, if the moon is up, go to the moon.
Yes.
The idea is to find the brightest object you can in the sky, except the sun.
No, yes.
Okay, don't do that.
That's a big
We'll have a separate
no.
show. Yeah.
We are. We're going to have a solar observing show in the future. Yes. But yeah, don't ever look at anything, the sun through anything with lenses. That's our rule. So yes, keep going.
All right. So what you do is you point the telescope at something super bright, either a moon, go after Sirius, whatever the brightest star is you see in the sky. The reason is that's going to be the easiest for you to find. And you can get yourself close by using your finder on wherever it happens to be, as long as it's mounted and pointed the same direction. But anyways, get your telescope centered on that star. And then if you could do it a few different ways. If you want to be super precise right now, like I get really critical about how centered my finder is, once you get the star or the moon centered, put in the highest power you have so you have a most close-up view as you can, and then make sure you're centered there. So you'll notice that if you have a lower power, you're looking at a larger field through the eyepiece, and you may not technically be centered. Once you have the object centered in the telescope, then use whatever type of adjustments your finder has so that you fine-tune and adjust your finder so that it is now looking at the exact same field with that object in the center like your telescope is showing. And here's something else to keep in mind though. Your telescope and your finder may show you a different perspective on the object. In other words, a refractor, if I remember right, flips the image upside down.
Yes.
And then if you put a star diagonal, which
wait, I have
don't
one.
think you
I
can
have
see
one.
my camera. I have one
Here.
that I'm holding up, but
Oh, do you? Okay, wait, here. I've got one.
that's better to show that there.
Star diagonal. Here, refractor comes in, and then what happens here?
And then it actually will flip it another direction.
So it's upside down and backwards.
Yeah,
So
upside down and backwards.
you'll make the thing go, you'll see it through here, and you'll be like, oh, I have to go up and to the right. And then you'll do that, and it's just wrong. And it's really
Right.
frustrating.
So, yes. So what I like to do is if I'm super far off, for instance, when I use my 20-inch telescope, which can be a little more difficult to adjust the finder, I start with the moon, but then I'll go to a bright star where I can see some other stars around it. Then I can compare what direction I'm actually moving. Do you happen to have your Telrad with you?
Yeah, I do. Yes, I do have my Telrad. Keep talking, and I'll grab it.
Okay, great. And so this is an example when we're using a powered finder. In other words, the image is magnified a certain amount. Now, while this telescope has a powered finder, when I use my Dobsonian telescope, in other words, where it's just a big tube, they call it a light bucket, on those I use a Telrad. That's an example, and there's a few.
This is an
example of a zero power finder. But the principle is the same. The Telrad has 3 little adjustment dials, and what's neat with the Telrad is you simply lay your head down like you're going to go to sleep on the side of your telescope, look up at the sky, and it has a little plexiglass window that will allow you to see a red dot. Yours looks like a dot.
This one's a dot. I got the Telrad down here, but it's still in a box, so I'm going to open it.
Okay, gotcha.
Keep going.
Yeah, so either it's a dot, and then with the Telrad, then it also projects a series of circles.
Yes.
Now, what's neat with the Telrad is those are actually specific amounts of arc seconds.
Yeah.
And I can't remember what they are. I believe it's half an arc second, and then going out for the, so I won't say what they are. But anyways.
Okay, so Tom Fry, you should be talking right now, Tom Smith, and Dave Majors. I actually haven't used this. This was what Santa got me. See, it's not actually mounted.
Yeah.
So I don't remember. So yeah, if you know what it is, type it in. Go ahead.
Yeah, so anyways, it projects a series of circles on the sky that allows you to very precisely see what objects are in relation to other objects. Yes. So again, that's an example of a zero power finder. No matter what you have as a finder, the principle for aligning it is the same. Start by aligning your telescope and pointing it where you want to go. Then make your finder show the same thing. And then you're good for the night.
Yes, and I have a picture of it right here that I can share. Oh, you're going to have to stop. Nope, there we go. So yeah, it looks like a bullseye like this. And mine actually goes green and red.
Really?
Yeah.
That's new.
I didn't know it was a thing. I thought it was broken. I'm like, wait, it's green. And then you flip the little thing and then it's red. So yeah, I can't wait to try this.
Well, that is, sometimes the red can be a little difficult to see in contrast up against the sky.
Yeah, that's true too.
So that'll be interesting.
Hey, Aurora?
Yes, sir.
I've got kind of a story that's tied in with finder scope.
Okay, you are our last little piece of content for tonight. Go for it.
Yeah, I had a Telrad finder also.
Uh-huh.
The problem was I just had a really tough time with it because it had such a large field. So, but they had a problem with weight balance. The Telrad is real light.
It is.
An 8x50 straight through finder has some weight to it. When you put it at the end of a 20-inch telescope, it gives a lot of torque.
It does.
So I added all those, remember all those weights that I had at the back side of my telescope?
Yes.
I had a bunch of weights I put at the back.
I do remember you putting those in.
That was actually to compensate for my straight through 8x50 finder. The thing I liked about the 8x50 finder scope is I could see a lot of the Messier objects, like M51 through the 8x50s. I could see it as a little blob, but I could see it. And it was also kind of like having half a binocular. So look up with a binocular and then look up with that. The only problem is the image is upside down and backwards from what it shows in your chart.
Yes.
So you got to kind of get used to that, by switching around your head. But that was a nice thing about having a magnification with your finder scope.
Yeah.
Is basically you can see a lot of the objects, even though very faintly, you can see a lot of the objects you wanted to go for. Where a lot of people love the televiews. It's just, I wasn't one of them. But
that's okay.
Whatever works for you is the important thing. You need some sort of finder. It's like having a gun without a sight. You definitely need a sight on your telescope.
Yes. Oh, here, wait. I've got a picture here of a couple more scopes. This is Lee and Tom Smith. Tom, thank you so much for all your answers on the call tonight. I don't remember. Oh, no, this isn't the one with Lee. Lee has two telescopes poking up. I can't see the other side of this one. Here's another one. You can see he's got, I can't see his finder on that one. And you can see one over here as well. So yes, you definitely need a finder. It's up to you to find out that one that works best for you. And apparently nobody has a Telrad up, so everybody's got one of these. So don't worry about it.
Yeah, I was first trained on a Telrad for Messier marathons.
Oh,
so
okay.
I'm very used to them.
You're very used to it.
And so on any Dobsonian, that's my go-to.
Yeah.
No pun intended.
We did have a question about wheelchair, so let me just answer that one really quick. So if you're in a wheelchair and you're looking for a scope, Dobsonians can be a really good choice, because if you look at these that are here, this puts the scope up high, and it can be really hard. But if you take a look at Kent's, for example, they have Dobsonians that are much shorter, smaller. You don't have to get giant ones like this. They actually have like the telescope I showed you over here will actually be mounted on the where the base is actually low down. So this is also really good for kids who, they're excited and then they knock the telescope over because it's teetering way up there. So if you just look for a Dobsonian that is mounted on the low down, they actually are the best telescopes to get for the money, because you're not paying for the mount. There's no tripod. It's just down there. You're paying for a much smaller mount. And you can also pipe that into, and they have go-tos now, which is great. And so you can pipe that into your computer program as well. Brian, we're going to have to do something in astrophotography, just looking at all the questions that came in.
Yes, we have lots of questions coming in.
We'll do that.
Definitely.
More equipment recommendations are on the very last page of your handout. Please refer to that as well. We love being able to share all of this fun stuff that we all love. It's all fun, right? Because it's all gear. It's like having gear. It's so cool. The gizmos and all that kind of fun stuff. But check this out. These are our personal recommendations. The Dobsonian I mentioned is there. If you're a kid, if you're a grown up, there are different recommendations. Also, if you have I put my cell phone in here. You can use this to mount it on your telescope, or on your, not your telescope, on the L bracket for the binoculars. Let's see if I put it over here. So where the binoculars kind of attach right here, you can actually slip this inside, and then I will have it on like Sky Safari or something like that, so people can see what they should be looking at, and then they'll look through. Binoculars are easier to initially start to look at. It's hard to learn how to look with just one eyeball. So that's another reason. So when I bring this out for public stargazing, I'll have this attached, and so people can kind of see it and see where in the sky that they're being pointed. So, all right, I think we're gonna go ahead and we're going to go ahead and wind things up. But do you have any quick last minute questions really super fast, Brian?
I think we've covered everything that I can
Okay.
remember or think of. Yes. Oh, we did have a question on magnitude for brightness, but I sent a response.
You sent a response.
I sent a
Okay.
response for that one, and we'll bring a refresher on that for next month.
We will. The next one we're going to be doing will be in February. If you're not on our list, make sure you get on it. Go to centralcoastastronomy.org, get on the list. Please, right now, go ahead and type in a comment. Let us know how you enjoyed tonight's session, what you enjoyed the most, what you now know that you are so excited about. We talked about 4 different constellations and a lot of really cool stuff you can see, super easy. And that handout is yours. Please share this with as many people as you can who you think would be interested in learning about the night sky. And go ahead and subscribe to our YouTube channel. That is the best way you can stay connected with us as well. If you'd like to join our club, you're welcome to. It's $20 a year. You can join from anywhere in the world. And if you'll notice, there are no ads on any of our content, and your being a member helps us do that as well. So Kent, are you still there?
Yeah, still there.
Thank you so much, Kent. So everyone, I'm just going to echo everybody's thanks to you. So woohoo, yay, little mini party over here, yay. Thanks so much for sharing. I don't know if you guys know this. When I first started, my husband gave me he gave me that telescope, this one over here. This one. This was my first telescope. He took it apart and put it all over the house, and I had to find all the pieces and put it together. Then I didn't know where to point it. Like I did things backwards. I didn't get the binoculars first, so I know firsthand how frustrating it can be. I would park myself right next to this guy. Here's Kent, and you would see like Aurora right there. And so just by being next to Kent and being able to ask him, what are you looking at now? Okay, where are we pointing? And just doing a little bit of the sky each time, and by the end of the year, you'll be completely amazed at how much you've picked up. So just don't try to bite the whole enchilada. Just do 3 or 4 of them, or if that's too many, just do 1 or 2 objects that we did tonight, and go out the next night, maybe do 1 more and 1 more, and pretty soon you'll have read through 100 National Geographic magazines.
The one thing that's really helped at star parties are the green lasers.
Yes.
For pointing stuff. I mean, that made a big difference when you're pointing out where things are.
Yes. Yes, very much. And so that's another great gadget that we use to illustrate where things are. So instead of saying right there, you can actually use a laser pointer to say, oh, it's actually over there. So I know that people have asked, can I put laser pointers on my telescope? To keep a green laser on for that long usually is not good for it. I've burnt out 2 so far, so I don't put them as a finder on my scope. I know some people like them. For me personally, I like these guys much better, and I'm sure I'm going to love this once I figure out which scope it needs to go on. Maybe I need a new telescope to put this with. You think so? All right. All right, Kent, well, let's go ahead and wrap it up. Brian, are you still there? Let's go ahead and say an official goodbye. Where are you? I'm not sharing you. There you are. So Brian, thank you so much for your help in moderating and your astronomical images, your astrophotography images. Were amazing.
Yes, it was a pleasure.
Yes, if you guys enjoyed Brian's work, please do let us know so we can do more of that. If you found it useful and valuable, we would love your feedback. It actually is, we're doing these because you had requested them. So how is it working? So let us know what you loved about the show tonight so we can do more of that in the future. All right, Kent, Brian, thank you guys so much. I will see you all next time. And so thank you, Kent. Do you want to say goodbye?
Oh, you're welcome. See you next month.
You got it. Thanks, everyone. Bye-bye. All right, Brian, say goodbye. All right. Goodbye, everyone. I will see you next time. Go outside, go stargazing, and I will see you later. Take care.